Hey all, welcome back to my channel Hi Ready. In today's session, we are going to see an interesting library that is used for creating visualization. That is Altair library. So let's get started with how to do that and how to work with this library. So the first thing that you need to do is you need to install that library into our coding environment. So for doing that, I am using pip install Altair and then I'm giving Vega datasets. Before that, I need to give exclamation mark. So I need to work with that right after installing. So for that, I need to import that. I'm importing Altair and then Vega datasets. Followed by that, I have something as this row, right? What is actually happening here? Here, using transformers and I'm disabling maximum rows. Why I need to do this specifically? In Altair library, it is not capable of handling data which has more than 5000 rows. So if I give a data set which has more than 5000 rows, it will automatically give me an error because it is not capable of. So for that, to avoid that problem, what I'm doing is I'm adding this coding line. So this will automatically remove the rows if it exceeds 5000 rows. The first chart that we are going to see that we are going to create is layer chart. So for that, let's try to understand how this coding works. For creating this, I'm importing pandas and then I'm creating a dummy data set first. Followed by that, I'm giving bars equal to alt chart of mark bar encode and all, right. So here mark bar means the vertical bars. Apart from that, I'm giving categories and values into my x and y axis. Followed by that, I'm creating points, which is equal to alt dot chart and I'm giving dot mark point at all. So if I'm creating a bar chart here I'm going to create a bar chart. On top of bar chart, I'll be adding a red line. So red dot. So for creating that red dot, I am creating this layer of creating point layer. So here x is equal to category, y is equal to value as similar to what you have seen before. Followed by that, the third layer is we are going to add the rule. The rule here is if I am having any mean value, if I am finding the mean value, on that I am going to draw a line. So for doing that, I am giving rules equal to alt chart of df. I am using the Altair library and I am creating a chart using the data frame. Then I am giving mark rule. So in this space, so for the mean value, when I give y is equal to mean value, for the mean value, draw a line on my chart. After doing this, the first layer is creating bar chart. The second layer is adding red dots on top of it. Then an average value, I'm drawing a line. So after doing all this, I need to layer them. So for that, I'm giving chart is equal to bars plus points plus rule. So plus means layering here. At last, when I give chart, it will be showing my output. So this is my final output. So first, it is creating the vertical bars. Then it is creating the red dot. And see the green line, thin green line between 10 and 12. This is actually the average value. The second chart that I'm going to create is interactive filtering using dropdown. So why I specifically need this chart? What is the purpose? So the major reason why I was creating a layer chart is because to compare the data category wise, to compare my values category wise. So for this particular chart, interactive scatter plot, it is actually a scatter plot, but it is quite interactive. I can change the particular categories and see my values. I can see my scatter plot according to my requirements. The main goal of this chart is users can explore data category by category. It reduces the visual clutter. If for three different categories are plotted at the same chart, it will not be easy to understand, right? So I can click on the drop down menu and see the scatters that I want to see. So it enables the user driven ability. They can easily analyze the data using this. Now let's try to understand the coding part of this chart. So the first thing that I'm doing here is I'm going to use a data set that is available online. So for that, I'm giving df is equal to data.cost. It loads a real world data set. It is going to load the real world data set. So here it contains cost specs like hours, power, mpg, origin and year. Followed by that, I'm creating the drop down. That is why I'm giving drop down is equal to. So it actually creates a drop-down UI element. So where the options come from unique values of origin. Followed by that, I'm giving selection is equal to alt.selection, right? So in this line, what actually is happening? It stores the selected drop-down value and it links the selection directly to the data field. Followed by that, I am going to create the scatter plot. So for doing that, what I have to do here? I'm giving alt.chart of df and I'm giving mark circle. So for every scatters, you are going to create, for every scatter plot, you are going to create mark circles as an identity. So based on that, I'm giving the encoding part. So for x, mark horsepower. For y, it is going to be miles per gallon. And the color is based on origin values. If the origin has three categories, for three categories, we'll be having three different colors. So this chart generally declares what to draw. So we are declaring here, I need to draw circles. So it specifically encodes my horsepower and the MPG value. So here we are using color to differentiate the origins. So when I give dot add selection, it is specifically adding the interactivity to my chart. So that is how basically this chart works. Now let's see how to use this. For that, this is my output. When I click on this, like when I click on Europe, it changes. When I click on USA, it changes. When I click on Japan, it changes. So based on this, I could work on it. Followed by that, we have the third chart as faceted small multiples. First of all, let's try to understand what is the goal of this chart. Then let's get into the coding part. The major goal of this chart is to compare patterns across multiple groups. Then I'm trying to avoid overplotting. So instead of creating so many charts, I'll be grouping few charts and I can visualize what is going on. So it maintains consistent scale specifically. So this chart is also called as small multiples because here the small chart, the same chart is repeated for each category. That is what is actually happening here. Now let's try to understand the coding. First, I'm giving alt.chart, right? So inside this, I'm giving data.cos and I'm giving dot mark point. Here, I'm defining the scatter plot. And I'm using the same visualization logic for all groups. Followed by this, when I give dot encode, inside the encode part, what is happening? It actually maps my all data fields to my axis. So the color still indicates origin for consistency. And finally, when I give dot facet, this is the main part of the coding. Here, it splits my chart into multiple columns. One mini chart per region. So the one concept that is happening or that is working behind this coding is same question, but it has multiple views. That is what is actually happening here. See, whatever we created using drop down in the previous chart, everything is plotted in the same line. So we can see everything like Europe, for Japan and USA in a same chart. So it is like we are creating different charts with the same different data, but it is on the same line. It is actually combined. So that is why. So instead of creating so many charts and visualizing it, I can make it much easier just by using this facet small multiples. The next chart that we are going to see is confidence interval bands. So this name itself tells us more about the goal of this chart, why I need this chart. Specifically, if I want to visualize the confidence intervals around aggregated data values. Let me make it more clear. It shows us the differences, the variability. So it prevents the misleading conclusions. So it supports us in statistical reasoning. So in this chart, what is happening in the coding part? So the first thing is df is equal to data.cos. So here it contains multiple observations per year, right? That data I'm importing here. Then I'm creating an error band. Error band is created here because Altair computes confidence interval automatically. So no manual statistics is required. So for that, using Altair, I'm using an error band here. Followed by that, I'm giving dot encode. So here is a category-wise data. MPG is a numerical data. So based on that, here is plotted on x-axis, and MPG, miles per gallon, is plotted on y-axis. So mainly the goal of the chart is it shows us not the average value. It shows us what is the difference. What is specifically the uncertainty that is happening, which is not about average or what is common. It's about what is different, what is the difference. So that is why we need to create this chart. The last chart that we are going to create is declarative statistical plot. So what specifically is this chart and why do we need this? So this is actually a box plot which we created for outliers and all. But what is specific about this and what is unique? So in this chart, it is capable of understanding it. What is the outlier, what is the quartile, and it can easily understand and identify the spread and outliers. So it can summarize large data sets clearly. So for this chart, try to understand the coding. It is very simple. So whenever I try to create a box plot with other libraries, the coding is quite complicated, right? But here the coding is quite simple. That is why we need this library. So specifically what I'm doing here, see, first I'm giving alt.chart for using the data set, and then I'm using mark box plot. So here it requires my statistical visualization. So my Altair library handles quartiles, median, outlier values. The next part of coding is simply I'm encoding it. So here I'm grouping my data by region and I'm showing my MPG distribution per group. So the major goal of this chart is it creates a statistics value with one declarative statement. So we do have so many libraries that create box plot, right? Why I need this? Because see the line of coding that I've used here. It is very simple. That is why we should choose Altair over any other charts. So I believe you clearly understood how to create these charts and you have clarity on creating new charts with the same library and for your use case that you are using and for your data. So if you have any doubts, without any hesitation, drop them in comments. Bye for now. We'll meet you in next amazing video.